It's not even live. Hey Bartholomew, how are you? I think you, I think you sent the message before we were live even. We are live. This is amazing. I really love all my online friends. Yeah, cool. So, what are we doing today? I'm gonna try not to talk too much, as always. As always, I'm gonna try not to talk too much. What I'm gonna try and do is basically, actually, let me just do that. What I'm going to try and do is just jump into the code as soon as I can, so that we can go. So let's do documents. I think this is in HDL. I think this is in tiny CPU. Yeah. And whip. Control Shift D. And then I think so. Yesterday we did this thing where we managed to do some sort of test. We did up your. I think I can do up your test, and that should test something. That should run a test, and we can see some test output, and it says it's successful. And at the same time, we can say up your sim, and I think I can say main TBV, and this should actually open GTK wave for us and do some visualizations of the signal. We're not actually running it properly right now, so let's actually connect everything in here so that it actually connects and runs properly. That's what I've spent. I went on this article and I think a few more things, and I tried to find out how to do it, and I think I have an idea. That's what we're gonna be putting in today. Okay, cool. And I'll jump in between writing code and taking questions as much as I can. So if you're joining us and you have some questions, please leave them in the comments or just in the live chat, basically. And then as well, we do have a Discord community. Join us if you would like to discuss things further and see where we can go. So I think the thing I'm going to start doing is just start going for it, and let's write some code so we don't do so much exploring today. I like exploring, but sometimes we have to write some code. So the first thing I sort of discovered is I do not need this. This was just me copying the other code just verbatim. That's the first thing I discovered. I don't need that. And then I realized that we need some sort of monitor. That's why our test cases are so blank. Our test case should actually tell us what is happening. So we need some structure called a monitor, and a monitor enables us to do observations into the code that is happening. So what I'm going to do is I'm going to add a monitor first, and then once I add a monitor, we can I'll add a monitor, then we can run it and see if actually changes anything, and then we can add some assertions. I think today we're gonna assert on the slow clock. We can assert on the increment instruction. We can assert on register 0 being 0. I think those are the first three tests we need to, because otherwise, number one, we need to make sure that our tests are actually running properly. So before we actually go for anything else. So initial begin. So this is just like the app, and then end. This is the stuff that is going to be set up in the beginning. Do not be South Africa and say that. In the beginning. So this is just like the customary stuff that is set up so that we can see stuff. This actually will enable us to see more printouts from this. This should print out stuff, not just say it ran the test and it finished. So this is the first thing that we're going to do. And you use a monitor for this to show human readable stuff. So T equals, I think 0. Here we're going to do T equals 0 T. 0, 0 T. Okay, so this is so we can check the time, I think. Let's see. And then here we can also assert that the slow clock is slow CLK. So this, and as well, this will enable us to see waveforms on the how do I call it, on GTK wave. And then let's check on the PC. Let's check on the program counter. Let's make something that enables us to check on the program counter. So that's a decimal. And then let's do R1. R1 is equals I think is equals D as well, I think. And then we want to do, I think there's R2. I don't know if we're gonna use R2, but let's actually put it in there. In the end, we might have to like write tests for every thing, but we'll see about that. Okay, we'll see about that. And then besides that, what I want to do is I also want to sort of include the LEDs. Yeah, LEDs equals here. This will be a structure of R B. I think I can do G B. Can I do that? I don't use this, and I don't. Yeah, I can just leave it at that, and this is not equal. Remember, I'm just getting used to this. This is also a byte. Okay, so there's that. And then I'm going to put this here, but that's not a termination because we need to keep going with this. I will once I do this, I'll go on with questions just now. So we've made a string. Let's intersperse the string with the data item. So time, okay, and then in time, and then we'll take you dut.slowClock. And then dut.cpc, I think, and then dut.r1, and then dut.r2, and then I think dut yeah, I just can't call it like that. So this is ROM. Get from ROM, get the program counter. I think so. Is that what you're saying? Clock, program counter. Or what do you see? What do you see? This can actually just go be the PC itself. And I think R1 is the one that's going to be, R1 is the one that's going to be, R1 is the one that's going to come from here, ROM, ROM PC. I think so. And I think I want to put this on the next line. So DUT slow clock, DUT slow clock, DUT PC, DUT ROM PC, DUT. And we can't just say DUT PC. We have to say DUT.PC. Isn't it? Yeah, I think so. Because we're in the test environment. So everything here will have to be accessed by the test environment. So, and then in here we want to actually do that. And then DUT.R R2. I think so. And then at the end, let's put in lead red, lead green, and then I think lead blue. Okay, and if I actually do this, sorry, the sun is in my eyes, but I'm unwilling to close the curtain because let's just run a test and see. Up here, test. This might just explode, but let's see. you can work around PV 20. 21, 20. I think this is a problem that I will fix somewhere as I'm going. Oh yeah, okay, cool. Thank you for noticing that. I'm missing an instruction here. PC. No, actually, let's, because the ordering matters. Equals, this is a byte. Is this a byte or instruction? An instruction is a byte, yes. And then R1, and then R2, and then LEDs. And then does this actually time DUT slow clock, DUT PC? PC is the instruction. So PC. Program counter, and then DUT PC is the program counter, but DUT ROM program. If you read the address in the program counter, you get the instruction. So that becomes a byte, basically. Okay. So let's run that. Let's test that again. And this might be because I need to intermediately pass them into monitor later after I actually start doing the assertions. Okay. I realize I don't think I need this. Because this is from the previous test. So the part, and unfortunately I have to go close this window because I cannot see. Much cooler. I don't like it, but much better. I'll stop for 5 minutes for questions, and then we'll go on with this. We're up. Yeah. Hey, Peter. Welcome, Peter, to the thing. Hey, Nathan, as always. Yeah. Cheers. Let's do some stuff. Yeah. So if anyone has any questions so far, you can ask them, and then I can keep doing this. That end. Okay, cool. So it's fine. We'll make this sort of kind of work. The other thing I realized yesterday, I don't want to go back to that. The other thing I realized yesterday was I was asserting on the pseudo assertions that we had yesterday were asserting on the oscillator itself. If you think about it, they were asserting on the oscillator itself and not on the slow clock. So anyways, all the timings that we were going to have then were going to be wrong, really. They were going to be wrong. All the timings were going to be wrong. So what we need to do is actually, let's try this. Run CPU for some cycles. Say 40, okay? And then inside that, repeat. So this is just learning how to write Verilog again. Repeat 40, begin, and then I want to do an end, and then in here, repeat 40, begin, and then in here, what I want to do is to check at pose edge, not clock. This was clock before. At pose edge, slow. We can actually go this DUT dot slow CLK. Okay, so we are now do everything that is all the assertions that we're going to put in here are going to happen for when the slow clock is on positive edge. So if you can realize the difference between the code that was here yesterday and this one now is that the one yesterday was going to oscillate or check the fast oscillator, and this is actually checking our actual CPU clock. Okay, and then let's start with the simple one. Let's check that R0 is always 0. This is a RISC-V thing, so we need to kind of make sure it always It always happens that way. So if we want to make a RISC-V processor, DUT, and then in DUT I want R0, no, R0, sorry about that, R0, am I doing this right? No, DUT dot, isn't it? And then this I want to say is not equal to 0, yeah? If it's not equal to 0, then I should do a begin, okay? And in here I can write some sort of thing. And I learned of this, fatal. This is basically fail the test, So fatal, fail, RO, R0, changed, R0 change value. Value is equals to, let's put in 0D. And then here we need to do DUT dot R0. Even if this fails when I try it now, I'm not necessarily going to go and fix it. I just want to, I'll remove this as well. We will just deal with this syntax later, okay? So actually, this seems to be our first test, doesn't it? I think we should do an assertion. I think we should try and run a test and see what to do. What happens? And I will do some questions. Up your test. This is good. This is good. Number 33, syntax error. 33, so 5 up. Somewhere here. At pose edge, GUT slow clock. Repeat 40 at pose edge, DUT slow clock. Ah, I see it. It's basically, okay, look, this is the error. You never use at pose edge without the brackets. Okay, cool. So here we want to do we want to do that, and then in here we want to go this. Yeah, I think this should fix it. This should fix that fail. Let's run that. Fatal's finish number must be numeric. Fatal's finish number must be numeric. So what am I doing wrong here? Fatal's finish number must be numeric. And I did not know how I messed that up. So if DUT R0 not equals to 0, begin, and then say a fatal R0 change, and then in here we pass in a decimal, and then we read that from there. That should really work. So it should be end, and then finish. Okay. So let's remove this, I think. There's an initial begin up there, so we can do an end, yeah. And then in here, after this second end, we can do a finish. Something like this. Does this actually fix it? Because I didn't want to keep going too far. Main TB fatals finish. Fatals finish number must be numeric. Let me copy this. Let's see. Okay, we can do some questions. How did you pass the ROM to the CPU? I'm not passing a ROM to the CPU. We're just running the ROM as is, and because our ROM is static, it's just using it as is. Right now, right now, check this. Check this. Control E, ring V. Our ROM is inside. Our ROM is actually inside our CPU. So we don't even need to pass the ROM because it's part of the. It's actually statically defined inside the CPU. So we don't need to pass it. It's there. So why does it hate that? Why does it wait the fatal thing? And even that makes sense that it's no, it's mm. I'm just looking for how to use fatal. Just a moment. Fatal, for example, Verilog. So I learned today like what VLSI means, and it means like very large scale integration, and that's when you make the actual CMOS thing, and then suddenly computing becomes chemistry. Hmm. You know what? Can we try this? Can we just remove the? Can we remove the? Can we remove this? Can we just not do that? Our O change value, and then just we don't even care what it was set. We just say it was our O change value. If we do that, does that help us? I don't understand. I really don't understand. This is another one of those days where like I don't understand how I made it not work. You know? I don't understand how I made it not work. This is actually what I intended to do. Repeat 40 begin repeat 40 begin at post edge DUT slow clock. That is exactly where I want to be. If DUT R0 not equals to 0, then that point at that, and then yeah, and then why you want it to be a B? Do you want it to be a B or something? And what if I do Appio simulate, Appio sim main TBV? Do we even get GTK wave? No. Fatal's finish must be numeric. So this seems to be the thing we have to do. Copy. Immediate assertion. I really, I'll try and use a display here. Display. And then just see what happens if I do this. Okay, cool. So that actually changes. And then if I do appear simulate. Build fault, initial sim. Cool. So that doesn't, that makes it not work, but this display all tests pass, and then there's that, so I'm just trying to put in the code until my thing does not break. I'm putting in the code that was in before until my code does not break. What am I doing wrong? What am I doing wrong? I wonder what I'm doing wrong. It's insane. We want to look at Pico Ice. Pico Ice explorations. Pico Ice explorations, and then TestBench. This is exactly what we needed yesterday. Look at this. Look at this. Look at that. If I do fatal, actually, why not? Why don't we? That's a display, and that's a that. No. Okay. What if I do that, and then I go back and I say something like, there's also no monitor here. Anyways, what if I do that, and then I go back and I use this code and I say if not, is there an asterisk there? Is there a that? Okay. If not, APIO sim, okay, and then we do s. Why is it just one? Okay, let's just do that. That's fine. Let's do that. And then, is there a space? Yeah. Fatal. Let's do one, and then that, and then that, and then if not appear sim fatal there, and then we say R0 changed value, and then finish that as a normal one. Yeah. So let us try and run our test. Happy test. Appear sim. So, not working. Dump vars 0. Am I not doing dump vars? Dump vars 0. Appear sim fatal 1. There's another part. our thing is not actually exploding now. That's good. Let's use display. So yeah, if we can do display R0 change value, okay, error at cycle, OD R0 what is R0? It's R0 equals to D expected 0, and then here I want to do LEDR. R0 yeah, I don't care about the cycle because we're not doing the cycle here. Are we doing the cycle still? Where are we getting the cycle? Are we doing the cycle here? Cycle is clock here, so I'll remove the expected for now. Error. Okay. Let's test this. "38 is malformed." 38. That. DUT dot. Somewhere I'm messing up with this. This whole thing. So time is 0t, and time comes from. Time will come from where? Time will come from. Time is it looks like it's a primitive inside Verilog, so that's not a problem. And then slow clock is going to be a binary because it's going to be either on or off. Which edge is it going? Okay, cool. And then the PC is going to be a decimal because that's actually from the thing. And then DUT-ROM, DUT-PC is the actual instruction. That's going to be some binary stuff, so that's fine. And then R1 is going to be an address, and that should be R1. Okay, cool. And then R2 is also going to be an address. We can point it to R2 as well. That's also D. And then we have some LEDs here, and then there's a structure which goes R, it's a byte, G, it's a byte, B, it's also a byte. Okay. And then there's time, goes with time, slow clock goes with slow clock, DUT PC goes with DUT PC, DUT ROM, and then in there get the DUT program counter, gives you an instruction, cool, and then DUT R1 and DUT R2 actually gives you the two registers, R1 and R2, fine, and then there's lead red, lead green, lead blue, lead red, lead green, lead blue. Ooh, that's a hard thing to say, but I was missing that part over there. If you noticed, I just added that. So let's see if that actually fixes anything, or do we have to start googling about? Just a moment. What if we pass? What if we do this? What if we just comment this out? Because this is just a monitor. Okay. I just want to see if this actually does change anything for us. So this is just a monitor. Fine. That gives us human readable stuff. It's running 40 clocks. It's running 40 clocks. It's running 40 clocks and then it's gonna stop. I think another thing we need to do is probably just do I and then do 5. 5 is enough. 5 of the slow ones is okay. And here. Yeah, that's fine. Okay. Up your sim main test bench. Please open GTK Wave. I have made an infinite loop somehow. I've somehow made an infinite loop. That's what I've done. I've made an infinite loop somehow. This begin goes with this end. This begin goes with this end, and that's it. Let's see if this has a syntax error in it. If the error is here. Okay, so that is the error. This will give us GTK wave. That's fine. And in GTK wave we'll get like DUT, and in DUT we'll get, yeah, it is exactly what we want it to be. So there's some problem. There is a problem. GTK wave works. Tests work. If I run all tests and then it calls TestBench, all tests pass. Yeah, so all the tests work. That our test bench itself actually works. Wait. I want to go look at this. Ooh. See that? I think that might be it. Let's not actually use this. I don't want to use this. Let's use a thing we know about. So let's use a 4. For I is equals 0, I is less than 5 for now, and then I is equals I plus 1. And then here we can go begin. And then let's say 5. And then here, let's actually remove this comment. And then here, we can actually put that back there. And then if we want to just be clever, we can just remove this and do that and remove that, just so we know that everything actually works. So up your test. Clear. Up your test. I'm going to stop for questions just now. Let me see. Oh, I is not known. I is not known. Where did we get I from? For I, integer I. Let's actually see up your test. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. No, it's not going well. It is not going well. So I want to stop that. Yeah. And what if we actually use the clock itself? Let's actually just use the clock itself. CLK. Okay. And then cushion shift there. And then we go up here test. Okay. Perfect. That actually works. And then up here sim main tb.v. It should give us some signals at least. I don't see any signal. I don't see that. I don't see it oscillating at all. I do not see any signal oscillating. Some reason that is odd. Is this because there's no monitor? Okay, and what if I do this now? What if I do that and then I go and leave this assertion in? Do our tests actually pass? It works. It works, but we don't know how to access do I need to pull it from the... No, I don't need to do that. I'm wondering if I need to add it here and add it there, but that doesn't work. So that is X. It being X is actually really good. It being X is actually really good because X is the default. X is the default thing. X is the default. If you just instantiate a register, X is the default register. Let's try something like asserting on registers in Verilog. Could that be why? Could that be why? Is this just sort of, this is 42, that's fine. That's actually the same. Could that be why? Yeah, I see we're also getting X. X is like the default thing. Yeah, this already happens. But A, what is A? Okay, this is a tempo. You get it. Look, they have a clock, they're A, they're B, dot C. It seems like the thing they're doing is they're always exposing. They actually expose the value that they're getting, which means we have to maybe change our code so we expose it. See here. See here, there's outputs for registers. See here, there's outputs for registers. And that's we don't have outputs for registers. But in any case, they do set their clock to 1 and then they oh yeah, there's that. What do you mean the result? How do you run it? Are you showing me? Are you gonna show me? Oh, shame. I thought they were gonna. Oh, I thought they were gonna show me the like something, like either the test flow or something. Does anyone have any questions so far while I'm thinking about how to fix this? The other part was actually to get this. Let's see if we can get the answer for this. Can we do that? And then that. I would settle for seeing one of the values rather than actually just failing well through. So that's fine. That's fine. All success. It's actually telling me what I need to do, but I just don't understand enough Verilog to know what to go and do. I have to go and read. I thought this would be easy. This is actually cool. And this is cool because what this is forcing us to do is go and read a lot of Verilog out there. And I'm actually seeing how people write Verilog because like that, like you see there's an interface there's an analog interface that someone is implementing here, and It's quite cool. So they're basically doing, yeah, it looks like actually a temperature sensor with a, yeah, something like that. Could be, but it's just cool. This is how you. This is one of the best ways of learning. When something doesn't work and you need to make it work. Yeah. So let's see here. Control F monitor. Mm. Lots of people. Uh, yeah. Do we have any questions so far? Do you have any questions? Uh, Verilog test bench for 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 CPU registers. Yeah, I already looked at this. It doesn't help. Yeah, maybe this P37X is a CPU. I think Verilog test bench as well. Let's look. Let's look. Let's learn. Oh, this is insanely hard. This one has a pipeline in it. I don't know. I don't know. I don't know enough to see that. I'm sorry. I'm sorry. That's a big one. Yeah. Thank you. This is insanely hard. This is yeah, this is something that has a data path, which is the hardest thing I'm trying to learn on Verilog, I say. Okay, cool. Let's just put that aside. Leave that aside for now. Verilog text bench. Okay. This is exactly where we need to be. Okay, Verilog test bench. How old is this? Do I need to be worried about how old this is? It's fine. It's just chip verify. Okay, cool. A Verilog test bench is a simulation environment used to verify the functionality and correctness of a digital design described in the Verilog hardware description language. The purpose of a test bench is to provide a way to simulate the behavior of the design under various conditions, inputs, and scenarios before actually fabricating the physical hardware. So basically, you can write a CPU in Verilog, and your CPU can actually go and get fabricated into an actual CPU. So it allows designers to catch bugs, validate functionality, and optimize designs without the cost and time associated with physical prototyping. Okay. Verilog test bench components, DUT, or design under test, is a Verilog module or design that you want to test. This is fine. This is okay. Our design under test actually points to tiny CPU, DUT. And that also brings me to wanting to check something in my code. This is called main, and my module is also called main. Just want to make sure. Okay, cool. It is called main as well, yeah. So that's fine. The test bench itself is implemented as a separate top level Verilog module. We know this. We know what a top level module is. A top level module is one that doesn't have a parent, and sometimes it owns some. This module is responsible for generating input stimuli for the DUT, capturing its output and comparing it with expected outputs. That's fine. This completely makes sense. So basically, what they're saying is this DUT module here is responsible for feeding our CPU on the other side with our CPU on the other side with actual data, and then running the CPU on the data we fed it, and then checking the output so that so it will give it an instruction, run the instruction, and then check the output, check whether the instruction was run properly. This is all software extra. So yeah, this is actually what I want. This is exactly what I want. Any questions so far? Any questions so far? Do we have any questions? Doesn't have to be about Verilog. You can ask me about me as well. Or you can ask me about Zephyr as well. Where did you find this? Where did you find this stream? Tell me in the chat. Where did you find this stream? Module D large can be written in the following steps. So module TB large, all the TestBench codes. Yeah, okay, cool. Initial begin, set everything to 0. Are you telling me to do this? Where's our first initial begin? Do we have an initial begin? Let's put another initial begin here. We can have many initial begins. Initial begin. But does that mean DT00 ? Just show me the whole thing. Don't tell me that's how you make it. Yeah, I understand this part. This is actually a test bench. But check, they're using display, not monitor. And if I use and here and I do something like, but I don't even have TB, that's it, test bench, reg file, but this, so module, the CPU DUT. So can I say DUT dot R0 non-blocking assignment operator, that is equals to 0, and can I use display there, and that should actually do something for me. Let's see. Do we actually see what happened? Do we see what happened? Do we see what happened? That's amazing. So that's good. Did we just learn something? Did we just learn something? Is this written? Yeah, that's written. Yes! We figured it out! We figured it out! We got it. That's amazing! Okay, cool. So, we actually need to set the initial values for the data structures that this is gonna work. This is actually gonna work. But my problem is this dump file doesn't actually do the thing I wanted to do for now. So okay, so let's rush through and do something else. So we actually figured that out. So you have to actually initialize the things. So let's do another assertion. Let's do a scary assertion. Let's assert on the LEDs. Okay, if let's do lead red, if I remember correctly, lead green. This actually will tell us whether we lead blue, and then we can do that, and then we can say not equals to dut dot r, and then that is the dot r, and then we go pick from the ROM, and then we go pick the PC, and then we can't just pick the PC, we have to do dut.pc, and then from there we need to pick the three. It's just the same thing we do in the code. We need to pick dut.pc, we need to pick 3 0, and then in here this, so we need to pick that, we need to pick that as an index, yes, and then in here we need to pick 2 to 0, if I'm not wrong, and then we can do begin, and I think we can do an end, but there's a syntax error somewhere. There's a syntax error somewhere, so that should actually highlight something like that. Perfect. And then in here, let's do we won't use a fatal, we will use if not. So this we know, we need appio sim fatal, and then in here, in the fatal now, we can do we can actually write our own assertion completely in here, and in here we can do something like, sorry, that always happens during the stream. In here we can do something like fail. This only happens if it does actually fail. Lead mismatch. I have a feeling this is going to fail because these things are going to be x's. Expected equals expected is equals it's going to be a byte, and then got is also equals to be going to be equals actually I shouldn't put a space here, that's bad, I shouldn't put a space here. Got is equals to byte as well. No. Why? I'm going to stop soon because it's on top of the hour, and we know we have to stop on top of the hour. Yeah. And then inside of that, we're going to do something like, let's also actually show the PC itself. Oh, my word, why? Am my stickers fingy or something? The PC itself. In here, we actually want to do, how do I say this? PC itself. So PC is equals to, so program counter is going to 0D. So in here, and then we can do a comma, and then in here we can now start actually doing some stuff. And then we can say dut.r, and then in here the first thing that we put in is dut.rom. I think no, dut.rom, yes. And then in here we want to pick dut.pc, and then in here in the PC, well, we want to use that dut.pc, and then in here we want to use 30. Yeah, just need to get used to this. And then in here, this is all our index, so that we can pick into 20, isn't it? Yeah, and then we can do that. Does that make sense? So let's see. So this will pick that. Yeah. So this comes here. Yeah, and then this comes here. Yeah. So what does this close? Yeah, that's fine. Yeah. So I'm gonna land in there, and then we can do in here, we can do lead red, lead green, lead blue maybe. like that, something like that. And then after that, we can also say dut dot pc. And then after that, that actually finishes, this finishes that. I think this is gonna highly fail because we have a lot of surface area to discover about this stuff. Lead red, so lead red. My cats have to be fed. Fatal's finish number must be numeric. So here we have to add a fatal, a numeric one. If not, up your sim that, and then can I do? You guys are joking. It's not that simple. You can't just do that and it works. It's not working. Time is passing. I can see days going by. Time is passing, but I do not see. I don't actually. Oh. Whoa. So the clock is actually clocking. I is actually counting. But I don't see my LEDs actually flipping. Run. What if I can I run it to like 600? Run it. I need someone who knows what mistake I'm making because this is working and I didn't expect it to work. So first of all, our thing. So let's go in here. Let's do this. Let's add a clock. Let's add a PC. Can we add that? Yeah. 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 We can actually see because it's we can see the values of these things. It's amazing. And if we run it, I don't think it's running. This is the thing. I don't think it's running. Well, the clock says it's running. So that's a different story. The clock says it's running. They do, the things have values. You see, the things have values. Let's look at slow clock. And if I run it, I'm not so sure whether it's running or not. That's a problem. I've only seen like on and off tests. So I'm not so sure that it's running. But we are getting the signals to this side. And the clock is actually flipping. So just that the clock is flipping means stuff is happening. I don't know why this should be zeros. The program counter is 0. And I don't know why it is. Does anyone have any questions? We're going to stop here. I need to go and ask more questions. I need to go and find out more because I expected either more fails. I expected it to completely fail or something. But what I'm getting here, what I'm really getting here, oh, okay, actually, no, that's the wrong thing. I don't want that. I really don't want that. It's going to the wrong screen. I don't want that. Up here, test. All my tests are passing. I don't understand why all my tests are passing. I mean, all of this has been taken from like reading all of this stuff online and kind of just trying to follow my brain through this. Okay? That's where all of this is coming from. And it doesn't matter how hard I stare at this, I will figure out if something is wrong or not. So actually what I'm gonna do is, let's actually type in the last test, and then I'm gonna go to work and see if someone from work actually can review this for me and tell me how, if I'm doing something wrong or if I'm doing something right. So let's do an if. Let's check the DUT. Let's check the program counter. If DUT actually not the program counter. Let's assert on one of the instructions. If we do an increment on a register, does it actually increment? Let's actually see that. If 3 DUT. Oh, I know why. So we can actually go. I think we did a 4 and I want to do a 40 here. I see now, 50 or something. That's fine. So here, if DUT equals 3 and if DUT equals 3 and DUT dot R1, So what we want to check is if we increment R1, when we come back, will it have been incremented? Okay, that's really what we wanna. That's really what the test that we're trying to do here. So let's actually do that and then begin. If this works, so it's either our CPU is working and we're just not familiar with this Verilog in itself so much that we don't know. And then also, maybe we should do something like display, but it would fail. Error, LED state mismatch. I don't see. So and then we should come here and then and then we should do like display let's do it in here. Let's say inc instruction not computed. Just say that, and then there's that, and then we can do an if not appear sim, and then in here we can make a fatal, hash fatal, and then in here we can do something like a 3. I think I need to go and learn why that is. And then in here, we can say fail, expected R1 to be expected R1 equals 1 after inc. Got D 0D, I think, if I'm okay, and then we can do here DUT dot R1 that, sir. I don't like it when they're like that, but I'm okay to do this here so that all the code is visible, and then I can do an and here. Actually, no need for that because I think this and here belongs to that. And then there's an end down here. And then actually let's see if this actually all works. This would be such a, I think it's gonna explode. Malformed number 57. 10 lines up. If not up your seam, yeah. Let's see. Nah, this thing is lying. It's lying. Why is everything passing? It's lying. Why does everything pass? It's lying. I feel like it's lying. I feel like it's lying. Everything passes. Yes. When we run our CPU, when we actually run our CPU, I'll connect it right now. When we actually run our CPU, we do actually get the results we expect. Yes. But it's sort of like too easy to write the tests. I think I'm making either like some fundamental error or like I understood this thing faster than I expect. That's really what I expect. I don't understand why it's working, but let's pull it out. Okay. Git status. Git add main.tv. Yeah. Git branch. Git commit -m. Add TestBench. Add a TestBench with working assertions. Okay, git push. I'll push that up. So we've written some assertions. They're working. Maybe it's because I've been trying to write these assertions for 3 days and failing, and today it actually worked, so I'm kind of shocked that they're working. I think next stream what we're gonna go back is to now move to implementing immediate mode instructions on the CPU. That's what we're going to go to. I'm gonna go to someone at work who's way more experienced in RTL or hardware design languages, or rather digital design in general, and I'm gonna have them look at my test bench. I'm pretty sure they're going to be able to point out some stuff that doesn't work the way it's expected. But for today, we wrote a test bench and we sort of figured it out on the fly. We Googled stuff, we read through stuff, we followed our intuition, and the code somehow simply works. Yeah, thank you so much for showing up today. That was amazing. I really look forward to getting super comfortable in this and starting to move quickly. So that was cool. And also, here's another thing. Here's another present from this morning. If you were here this morning, you would have heard about this little board, which is the STM32N6. It's a really cool board. It's got a GPU, this tiny thing. It's got a GPU, it's got an image processor on it. It's got quite a few features, and you would know that it wasn't working. But during the day, we on the Zephyr community, we managed to figure out how to flash it and stuff. So I can now actually write code and put it on this, which means we can do some actually nifty stuff, something like do some videos and do some UVC stuff, and it's gonna be amazing. Yeah. So thank you so much for coming to today's session. That was an awesome one. It was me struggling with a lot of Verilog and trying to see what happens when I press certain buttons. I learned a bit. I don't know how much I learned because I don't know how much is correct about the thing I built. But yeah, this is cool. Thank you so much for coming. That was an amazing session. See you guys tomorrow. And remember to keep trying. Write it broken, push it broken. Just do it. Do it till it breaks, till your time is done for the day, and then go back tomorrow and try it again. That's really it. Thank you so much for coming. That was an amazing session. Cheers, and see you guys and girls another day. Thank you. Cheers. Bye.